Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, let me introduce myself. My name is Keysa Salma Nazkia with student ID 124490060. And today in this video, I will be adding test point in my PCB and viewing Gerber file. Without further ado, let's get started. First thing first, you need to open your KeyChat. So just search up your KeyChat. And then we go to schematic editors. In here, we will add the test point in the power section in the 3.3 volt ground and 5 volt power. So if we go to symbol over here, we can get the test point from here. Alright, with that you can search up test point and it should appear. Just gonna load for a moment. There we go. This is the test point we will be using. Just click OK and place your test point near the power. We can put it right here, and then you can change the test point name to the name of the volt power. Like this is 3.3 volt, so just rename that, and then you can do the same for the other two. I'm gonna add it here for the ground and then rename it as GND or ground. Okay, and then duplicate it again using Control D to place it in the 5 volt and then change its value to 5 volt, then clicking OK. Now we need to add the footprint. To do that, just double click the component, and in the footprint here you can press this, and then you can search up test point with whatever test point you want. I will be using this, the test point path 1.5 by 1.5 millimeters. I'm using this because it is relatively small and very convenient. So I'm just gonna OK that, and then OK, and then do the same for the ground and 5 volt footprint. Press this, and then the 1.5 by 1.5. OK. And do the same for the 5 volt. Okay. Now we need to go to the PCB editors, which is right here. As you can see, I already built my PCB. Now we just need to update the PCB from the schematics because we had updated 3 new things. After you update it, you close it, and yeah, here it is. This is the test point. As you can see, the 5 volt, the ground, and the 3.3 test point. Now we need to place it near the test point of the respected volt power. Like for example, this one is 3.3 volt. Clicking F will turn it blue, and in the 3D, it will appear behind the PCB. So I'm just gonna connect this to the 3.3 volt. And for the 5 volt, it's literally right next to it. So I'm just gonna place it over here and connect these to this. And for the ground, I'm gonna place it right here because the ground is literally right there. Now, if we go to the 3D viewer, we can see the test point 3 over here for the 3.3 volt, test point 2 over here for the ground, and behind it is test point 1 for the 3.3 volt. Now I will be showing how to Gerber in the Gerber viewer. First, you need to go to File and then Plot. In here, as you can see, you need to pick the Gerber format. As you can see, mine is already in the Gerber format. Now we need the output directory. You can create a new folder. I'm just gonna write minus task 4, and then you can select this folder and then just click OK, and the output should be in that folder. So if we click plot and then it says it's done, we can just close this. And if we go to that file, so in here, and task 4, as you can see, all the Gerber file are here. Now, to make it viewable in the Gerber viewer, we need to select all of this, click right, and then compress it to a zip file. And I'm just gonna name it task 4 for task 4. Okay. Next on that, and if we go back to here, we can see there's Gerber viewer. So we click that. And then, as you can see, there's nothing here first because we need to open it manually. So we need to open zip archive file and select the zip file we just made. And the Gerber file will show up automatically over here. Now I'm gonna tell you a little bit more about my PCB. So this PCB is a 2-layer board designed using Keysa, where the red track represent the copper routes on the front layer and the blue route tracks represent those on the back layers. Vias are strategically placed to interconnect signals between 2 layers, while a large ground plane is implemented to improve noise reduction and signal integrity. The design includes 224 paths, 74 vias, and 475 routed track segments distributed over 71 nets, with no unrouted connections remaining. A keep-out zone is refined at the top area to restrict routing and components placement, ensuring mechanical or functional requirements are respected. Mounting holes are provided at the corner for structural stability. To facilitate testing and debugging, test points are added to important nets such as VCC or 3.3 volt and 5 volt and ground and communication lines, making it easier to probe signals during hardware validation. After completing the layout, Gerber files were generated for all essential layers, including copper layers, silk screen, solder mask, and the board outlines, and verified using KeyChat Grep View to ensure manufacturability. Overall, the PCB is neatly routed, optimized for reliable operation, and well prepared for both production and practical debugging. That is all for today from me. Thank you so much for watching. Wassalamualaikum warahmatullahi wabarakatuh.